Let's Science is brought to you by the StarQuest Production Network and is made possible by our many generous patrons. If you'd like to support the podcast, please visit sqpn.com/give.
3, 2, 1.
We live in a universe of scientific wonders.
Every day, scientists are inching towards breakthroughs which can change our lives.
We're playing our small part in sharing these wonders with you.
That's why today is a fine day for science.
So let's science.
So Caroline, topic that I love, exoplanets. I really, really want to see an image of an exoplanet, not a painting like from James Webb one day. However, over to you. Tell us about the latest discoveries in the area of exoplanets.
So, okay, I have to say this topic was inspired by my son Harry. So like every night before he falls asleep, he wants to talk about space. It helps him to fall asleep. So
Whose fault is that?
I may have inspired him a little bit. So yeah, we talk about black holes, we talk about stars and planets and anything else he can think of really. And then he'll ask me questions like, Mum, can a galaxy be eaten by a black hole? Or what would happen if Saturn was where the moon is now? Or what does the moon do for Earth? Or what would happen to us if Mercury didn't exist?
Great questions.
You know, the usual kind of questions that an almost 9-year-old wants to know the answers to. And
did you reply by saying, fetch me a cup of water?
yes, no. Usually I'm half asleep at this time and I have to get my science brain out.
Yeah.
And we talk about it. You know, we talk through what could happen. We talk about gravity. We talk about all of these things. And, you know, it is fun to talk about these things with him. And, you know, he also, another thing he likes to do before we sleep is like to watch YouTube videos about space. And, you know, and usually this is where, you know, the questions come from. You know?
Okay. Yeah, I can imagine that. Yeah.
Yeah. So today, this episode is dedicated to Harry. And yes, I wanted to talk about exoplanets because it's one of the things he loves to talk about. And, you know, he knows so much about it. It's really cool. It's really cool that my little boy loves them. So we have to talk about them today. So really, exoplanets are basically defined as planets that don't orbit our sun. So all the planets in the universe, except for our planets in our solar system, are exoplanets. And many exoplanets have been found by various research bodies and by different methods. And two of the most common methods are gravitational microlensing and the transit method. So briefly, the microlensing is one of the more commonly used methods for indirectly detecting exoplanets. It relies on the gravitational force of distant objects to bend and focus light coming from a star. As a planet passes in front of the star, the light dips measurably, which then can be used to determine the presence of a planet. And this method is best used for planets that orbit far from their host stars. And it's also a good technique for discovering rogue planets. And rogue planets are those planets who are not gravitationally bound to a star. They might have been flung out of their solar system, you know, through gravitational interactions with other planets. There might not have been enough room, so out you go. Then there's the transit method, which measures a drop in the starlight caused by planets with orbits that are oriented in space in a way that they periodically pass between their stars and a telescope. This method is also useful for revealing the sizes of planets as well as their orbital periods. So let's talk about a few of these exoplanets. Now hold on, okay? We're going to go for a little journey. All right.
At warp
Let's
speed.
talk. Yes, it will have to be because these are all quite far away.
Yeah.
So let's talk about one called WASP-12b. Okay, they all have interesting names. So this planet is a hot Jupiter, meaning it's a hot gas giant orbiting very close to its star, and this star is WASP-12. This one was discovered on April the 1st in 2008 by the Super WASP Planetary Transit Survey. This hot gas giant is almost 2 times the size of Jupiter. So imagine Jupiter, double it.
Oh, wow. That is a big planet. Yeah.
Incredible.
Massive.
Yeah.
It's 600 light years away and found in the constellation of Auriga. It takes this planet about 1.1 days to orbit its star.
Wow.
And it's so close to its star that it has a temperature of 2,210 Celsius or 4,000 Fahrenheit.
It's a bit hot.
Yeah.
Hot.
Okay.
Not a holiday destination.
That's definitely not. No.
We may not want to visit this. Look at it from afar.
Yes. Yeah.
Yeah.
The gravitational forces acting on the planet by its star are so strong that it has a huge tidal force that shapes the planet into an egg shape. So
Oh.
it's egg-shaped Jupiter. The star is slowly causing the planet to swell and break apart while its atmosphere is being stripped away.
Oh, wow.
The star WASP-12 is actually gradually consuming the planet, and in about 10 million years, there will be no planet left.
They've got time. They've got time to solve the problem. Right,
Yeah,
that's good to know.
so we have 10 million years to figure out how to go and have a look at this
Yeah,
planet before
save
it
the
disappears.
planet,
disappears.
Isn't that amazing? Crazy.
Yeah, that is
I love
incredible.
this.
I mean,
It's crazy.
even being bent in, or transformed into an egg shape
Yeah.
because of the strong
That's a
gravity.
massive star doing
yeah.
that.
No, that's a very
That's
hungry
very cool.
star.
Yeah.
Goodness me.
Very
Yeah.
hungry star.
Wow.
Our solar system is a nice and quiet place to be, so I'm happy to be
I
here.
did say. That star's trying to eat us. Yeah.
No, thank God. Okay, so the next one, HD189733b. Okay.
Great name. Easy to
This
remember.
one, yes, was discovered in 2005 using the Hubble Space Telescope imaging spectrograph. So on the surface, this exoplanet appears like a pretty deep blue orb. It's 64 light years away, and it is also a hot gas giant, slightly bigger than Jupiter. It orbits its star in 2.2 days. So the weather on this planet is quite fierce. You think our weather at the moment is crazy? Listen to this, okay? It has winds that blow up to 5,400 miles per hour, or 2 kilometers per second, or 7 times the speed of sound.
Yeah, but great for sailing.
Yes, great for
Okay,
sailing.
no, forget it. No, the sound waves will kill you. No, forget it.
Yeah,
All right,
amazing though. Amazing.
Yeah.
Its atmosphere is much bigger than expected and is slowly being stripped away by its star as it's bombarded by solar radiation. So this one's being stripped away. The blue color comes from silicate in its atmosphere, which forms molten glass after being heated up by its 1700 Fahrenheit or 930 degrees Celsius temperature. So not only would you have to contend with the amazingly strong wind, but you'd also need an umbrella that can protect you from glass rain.
Whoa.
Yeah, I don't think we've invented that yet.
Whoa.
No. So yes, that's another one put on your travel list. Maybe.
Yeah.
Maybe. If you're tired of the cold,
Come and see our molten glass rain.
yeah.
It's going to get all the
Amazing, huh?
tourists.
We complain about our rain, like, you know,
Yeah.
I'm glad it's not molten glass.
Yeah, well, yeah.
All right.
Yeah. When it rains,
So-
it hurts.
Ouch.
Yeah.
Oh, my goodness me.
Wow.
So next on the list, we have HD 80606b. This one was discovered using the NASA Spitzer Space Telescope in 2001. It's located about 190 light years away from Earth in the constellation of Ursa Major. It is a gas giant exoplanet about 4 times the size of Jupiter. Double it and double it.
Yeah, double it. Oh my gosh. Double that.
Okay.
Wow.
That is
Yikes.
massive. Okay. The interesting aspect of this planet is that it has a highly elliptical orbit around its parent star, which is HD 80606. It's thought that there may be another star in the system causing the orbit to be elliptical. So maybe one's pulling from one side and one's pulling from the other side. It takes about 100 days to travel towards its star. And then when it arrives, it passes by very closely to the star in a period of about 20 hours and then flings back out for another 100 days. During its orbit, HD 80606b experiences extreme temperature fluctuations. At its closest approach to the star, the planet is subjected to an intense heating, which causes the planet to heat up from about 500 degrees Celsius or 1,000 Fahrenheit to on approach to about 1,200 degrees or 2,200 Fahrenheit. And this fluctuation occurs with every pass by its star. It then takes about 10 hours for this planet to cool down as it passes away from its star. So, yeah,
Whoa.
gets cold, then really hot for a while, and then cool down again and in an elliptical orbit. It's pretty cool, huh?
Oh.
Yeah. Just thinking, elliptical orbit, so it moves away. Does the planet, do we know if it spins at all or?
Probably, I would assume. But I mean, I don't know if they can detect that kind of thing from so far away. But
yeah, right. Okay, fair enough. I'd be curious about that too. Yeah, like if it behaves like a normal planet on this really odd orbit.
I'd say so. It doesn't mention that it's a tidally locked planet. Some of them are, but that's the information I have anyway.
I'm just trying to work out how an elliptical orbit of a planet works. That's fascinating.
It's just, so instead of going round, so like a normal round, the sun, it'll be an oblong shape.
It goes out, right? It goes out.
It'll go out. So it'll go, it passes by the sun really close. So it'll go round the sun and then it has a long 100 days pass out. So it takes 100 days to go long ways, right?
And
Does that make sense?
Is it the gravity of the star that pulls it back in? Is that the idea? Or I mean, I don't know if you know the answer to this, sorry, but like
it is bound to its star. That's why it orbits, right?
Just interesting. That's not like a nice happy round orbit like ours, right?
That's why they think that possibly there is another star somewhere that is also pulling it, right?
Oh my goodness me, two stars on the wall. Oh wow.
Yeah.
Oh.
Yeah.
Which is not unusual for there to be binary systems. Actually, it's unusual for our solar system that we don't know of another star that's without star, right?
Yeah, totally understand.
Usually stars, from what I've read,
they're
usually binary systems. So
like Tatooine.
That's why it's elliptical. There you go. So let's go on to the next one. GJ1132b. So this planet was discovered by the M-Earth South Array team in Chile in 2005, and it was found using the transit method. This exoplanet is similar to Earth and is actually called a super-Earth. Now, a super-Earth is a planet which falls in the size category between Earth and planets like Uranus and Neptune. And they can have a variety of characteristics. They can be icy or rocky or have oceans and are more likely to be in the habitable zone of their solar system.
Cool. Okay.
But being a super Earth doesn't mean that the planet isn't necessarily habitable, but it could be, right? Yep. So this planet orbits a dwarf star in 1.6 Earth days, and it has a surface temperature of 137 degrees Celsius, getting cooler.
It's a bit better. Yeah.
From the previous
one. A bit better.
Yeah, you can do better. Yeah.
Or 278 degrees Fahrenheit. It's believed that this planet has actually had 2 atmospheres, okay? So the first atmosphere of this planet was thought to be made of a thick layer of hydrogen and is quite large, making the planet actually about the size of Neptune.
Goodness me.
But this atmosphere was lost when its star was younger. It would have been much hotter and the radiation from the star would have stripped this atmosphere away.
Ooh,
wow.
So then the planet has been reduced to the size of a little rocky Earth. The planet is so close to its star that the gravitational effects of the star create tidal waves that squeeze and stretch the planet to create violent volcanic activity. Gases from the volcanic activity coming from below the surface have actually formed a second atmosphere on this planet. So this is the first time a planet with a second atmosphere has actually been found.
Wow.
So the current atmosphere has an atmosphere of hydrogen, hydrogen cyanide, and methane. So this little rocky planet lost its first hydrogen atmosphere, but now has a new one thanks to the volcanic activity, which helps to replenish the gases lost to space.
Cool. Can you imagine these planets competing for tourists? Like,
I know, right?
You don't go there. Their atmosphere has cyanide. And you're like, well, at least we don't have molten glass rain.
Or alternatively, brag about the molten glass rain.
Yeah, that's right.
Anyway. All right, let's travel to last one. Ogle 2016 BLG 1928.
Almost had a normal name until you got to the end.
Good.
Okay, yeah.
This guy is thought to be a rogue planet and it's the closest one to Earth. It's actually thought there are 20 times more rogue planets than there are stars in our galaxy.
Oh wow.
These planets just roaming around, okay? And about 4,000 exoplanets have been discovered in the last 30 years. So it was found by the microlensing technique in 2020 by Warsaw University and created a blip lasting 41 minutes, indicating that this is a small planet estimated to be between the size of Mars and Earth. So massive planets observed by microlensing can actually take days. Smaller planets or medium-ish planets takes hours, and this gives an indication to their size. So the fact that this one only took about 41 minutes means it's a very small planet. The planet is thought to be rogue planet, but the researchers are actually open to the idea it could actually be a planet that is very far from its host star, and at the moment they're unable to find that star. It may be beyond the 8 astronomical units away from its star. So in comparison, Earth is 1 astronomical unit away from the sun, and an astronomical unit actually is defined as exactly that, the distance from the Earth to the sun, which is about 150 kilometers or 93 million miles away. So not much more really is known about this little rogue planet, but it'll be studied more in future. But they were just amazed that they found such a tiny one.
Yeah. What a great find. Yeah.
Exactly.
Cool.
So there we go, a little tour of just a very, very tiny sample of exoplanets in the Milky Way.
It's so cool. Like I said, I just want James Webb to be able to take a snapshot of one of these, right? It's been taking so many amazing snapshots of planets in our solar system.
Yeah.
It'd be so good if we could. Here's a planet you've never seen before with your actual eyes.
James Webb can take pictures of another galaxies out there. Sorry.
Sure.
Yeah. The telescope will be able to take shots of all these exoplanets for us that is slightly closer for us to see.
Even in our own galaxy, we can only so far see the planets in our solar system.
Exactly.
And I remember the excitement about seeing Pluto for the first time. That was around the time Harry was born. I'm still excited about that.
That was so
Imagine seeing another planet from another system or a rogue planet for that matter.
That is so cool. Yep.
Yeah. Thanks for that, Caroline. That's exoplanets is just such a fascinating topic, really. Just the idea, emerging over time that we're finding more and more of these planets either around stars or, floating around space, just hobbling along, doing their thing. It's so cool.
So good.
Awesome.
Hopefully we'll find out, obviously, in the next decade or two, we'll probably get so much more information.
Yeah.
Looking forward to, I'm sure you'll keep us up to date on the developments as we hear more too.
Definitely.
All right.
Let's Science is brought to you by StarQuest Media and is a fortnightly podcast that brings you the scientific wonders of our universe from a distinctly Catholic point of view. For more from Caroline, Lindsay, and friends, listen to the StarQuest show, Catholics of Oz. Find links from today's show at sqpn.com/science and find the Catholics of Oz at sqpn.com/Oz. Be sure to follow the show in Apple Podcasts, Google Play, wherever you can find podcasts, or on the SQPN YouTube channel. The generous donations of our patrons at sqpn.com/give make it possible for us to continue Let's Science and all the shows at StarQuest, which makes our nonprofit mission possible. You can join them by visiting sqpn.com/give. Join us next time for more scientific wonders, and thank you for listening to Let's Science on StarQuest. Here's another show on the StarQuest network you're sure to enjoy, Jimmy Akin's Mysterious World. Find the show wherever fine podcasts are found or at sqpn.com/mysterious.